Hello students, in this problem we have an equation that involves a square root. So let's figure out how we're going to solve this problem. I'm going to do it a couple different ways. The first way I'll show you, and then you can just stop the video from there if all you want to do is solve this. The other way I'm going to use inverse functions to go through the solution method. Right, so the first thing we're going to do is we're going to add 5 to both sides, and so now we have 5 on the right hand side. So I'm trying to isolate the x, but the x is underneath the square root, and the inverse operation to a square root is to square it, and if I square the left hand side I have to square the right hand side. And so now the square of the square root will isolate the interior of the square root, and that is a 2x minus 1, and on the right hand side we'll end up with a 25. And now I just have a linear equation to solve, so I'm going to add 1 to both sides. And then after I add 1 to both sides, I'm going to divide by 2, and we get x equals 13. So if all you wanted to do is solve this equation, you can stop the video here. But if you want to see an alternative way to do it using inverse functions, then you can continue on. So let's set the problem up again. All right. So here I'm going to imagine I have the function is the square root of 2x minus 1, and in a previous video we determined that the inverse function was the quantity x squared plus 1 over 2. So let's find out how to use inverse functions to solve this equation. Now remember, there's a nice property with inverse functions, and that is if you take the inverse function of the function, you get x. You just get x back. So let's see how we're going to use that. So here's our equation once again. We have square root of 2x minus 1 equals 5. I take the inverse function of the left-hand side and the inverse function of the right-hand side. So I have to maintain equality, so I perform the same operation on both sides. And then I will input the square root of 2x minus 1 into the inverse function. And I will input 5 into the inverse function. And when I do that, I should end up with x on the left-hand side. We'll see how we get there in a moment, but I'll just evaluate those. So the square root squared just gives me the 2x minus 1, just as in the previous method for solving this problem. And on the right-hand side, 5 squared is 25. And you'll see on the left-hand side, the 1's cancel, and then we just divide by 2, and we isolate x. And that was expected. The inverse function of the function just gave us x, and that is one of the utilities or uses of having an inverse function. And on the right hand side we ended with 13, which is the same result as we had before. All right, that's how we solve those. Good luck.